Closures. Closures are self-contained blocks of functionality that can be passed around and used in your code. They can capture and store references to variables and constants from their surrounding context. So in this particular section, we'll look at introduction to closures, we look at closure syntax, we look at trailing closures, and we look at how to capture their value. So first, let's dive into introduction to closures. Now closures in Swift are similar to lambdas in other programming languages. They come in three different forms. First one is the global functions, which are defined with a func keyword. The next is the nested functions, functions defined within other functions. And then we have closure expressions, which are unnamed or sometimes called anonymous functions or unnamed closures written in a lightweight syntax. So let's look at a basic closure example here. What I'm going to do is I'm going to say let, just reduce the size of this debug, let greeting closure equal to print hello Swift, and then I can call this greeting closure. So if you look at it, I'm not assigning the value of hello Swift and then printing it out. I am just calling this closure right here, and if you look at on the side, you'll see it shows like something is a function is calling a function, and then it has a function here. So this is how closures look like. This is how closures are defined, and if you see, this is how it works. This is the basic syntax of a basic. This is a basic example of a basic closure. So let's look at some closure syntax. Now closure expressions are a way to write inline closures in a lightweight syntax. They can take parameters and return values. Now let's look at a closure with parameters and return value. So let me say let's call it multiply closure, and to this I am going to give parameters. Say a int, b is of the type int, and this will return me an int in return a times b. So what it does is, if you see, it looks like much like a function without a function name, where I have two parameters a and b, and this will return back an integer which is return a times b, and you can have the entire calculation over here if it's a bigger function. And I'll say let result equal to multiply closure, and to it I can give two numbers 3 and 4. Now if I say print result, it will give me the result value. So instead of creating a function to call it, you can just create a variable and or a constant in this case, and pass the entire functionality to it using a closure and call that particular closure. Let's look at trailing closures next. If a closure if a closure is the last parameter of the function, you can use trailing closures syntax to write the closure outside of the function's call parenthesis. What do I mean? So let's say if I have a function which is perform some operation, and it has parameters a int. This is more like a callback functionality if you have used callback functionality in other programming languages. If not, this is what it does. So the last parameter is actually a closure, where I'm saying it's going to return back int. So if you look at the function definition, perform operation, a, b, and a closure is passed to it. Now in here, what I'm going to do is I'm going to say let result equal to operation, and I'm going to pass that a comma b value that was passed. I'm going to print the result. So what's happening here is when I call this particular closure, or particular function perform, I am going to pass, let's say, 7 times 3, and then inside the operation, or what I can do is I can just close this here, and for my third operation I will use the bracket, and I'll say x comma y, these are the two, in return x plus y. So this is passed as a closure to this, which result will call the operation with a and b, which is 7 and 3, and add those two numbers and print the result. 7 plus 3, 10, and there we go. That's so you can pass parameters and the operation that you want to perform for those parameters along with as a parameter. So this is how trailing closures work. Next thing is capturing the values. Now closures can capture and store reference to variables and constants from their surrounding context. This is known as closing over those variables. Now let's look at an example to understand capturing values. So first I create a function make incrementer, and I'll say increment amount is of the type int, and it returns closure with int, and in here I can say variable total equal to 0. I create whichever I can keep the increment value. I'll say incrementer is int equal to, and inside this I am going to increment the increment amount and return the total back. Say return incrementer. Now to call this I'm going to say let increment by 10 increment by 10 equal to make incrementer, and I want to increment by 10, so I pass this. I'll say print increment by 10, call that again. So what happens here is I'm saying, let's open this again, I'm saying increment by 10, here increment by 10, I say make increment amount by 10. So when it calls it, it will pass through this, it will increment the value from whatever the value is to 10, and then the next time, since it captures the value inside the particular closure, it will increment by again to a 10, not by only 10. So 10 plus 10, it will save the previous value, and if you look at it, it will pass me 10 and 20. This is how you can capture the values of a particular object and then keep on using it. One of the practical exercises that we can probably follow, you can follow along with me to see whatever we have done here, is start with basic closure. Now let's say if you want to create a basic closure, how do we create it? Create a list. Let's create a constant, say hello, which is print say hello world, and to call it I can just say hello, and if I run it, it will say print hello world. Next thing that you can also practice is closure with parameters and the return value. So let's create a add function which takes integer and the return type is integer, and inside here takes two values a and b, and in I'll say return a plus b. Now I hope I didn't mess up. Okay, a plus b. Then let's say let sum equal to add, let's give two numbers, and let's see if it prints that properly. It does. 3 plus 4, it goes through this, it takes the two arguments, and inside this, without creating a function, we have assigned this value and we get that value back. Next, let's look at the trailing closures one more time. Function, let's create a function of calculate. This is when trailing closures is one when the last operation or the last parameter is a closure. int, b is int, and then operation is int comma int, returns back int, and inside here, inside the function, we can say result equal to whatever operation we are passing. I want to pass these values a and b and print the result. Now below I can call that, I'll say calculate a is 10, b is 5, and instead of creating this operation, I will say the first parameter, if I can use 0 minus $1. So it will take the first one and the second one and pass that values here. And if I run it, pass 10 plus 5, I think is the, so, oh sorry, 10 minus 5 because I gave a minus operation first, minus second, and that's how a trailing closure works. Now let's look at the capturing values, the last thing that we did with make multiplier. Last time we did addition, so let's do multiplier. Multiplier, if I can type it properly, integer, and that returns an int. I mean, it takes an integer value, and here say return num in, return num times uh, whatever the multiplier is. So make multiplier has a multiplier instance which comes back integer. Looks fine to me, cannot find. Okay, I need to probably let multiply by 3 equal to make multiplier. And why is it not giving me the values? Maybe I have some error here, but let's, and then finally I will say multiply by 3, pass it the value 4. Let me run it and see where did I make up bad habits, old bad habits of using full function names. Let's clean it up, run it again, and there you go. 4 times 3, 12, where we are passing make multiplier function here, passing the 3 value here, and then this will return back, capture the value, and then return it again and again. I call it, it will capture the value, and if I run it, it's going to call 3 because have used the value 3 here. So 4 times 3 is 12. Now here in this particular section, you have learned what closures are and their different forms in Swift. We explored closure syntax, including parameters and return values. We also practiced using trailing closures and capturing values with closures. Now closures are a powerful tool in Swift that allow you to write flexible and reusable code. The next section will cover object-oriented programming because we already looked at some classes and stuff, so we want to go over that before we do more in depth into classes, structures, properties, and methods. So if you have any questions or any problems understanding this, leave me a comment and I'll try to clarify them as much as possible. But we'll jump into object-oriented programming next.